This is a lesson on systems of equations, and we're going to take a look at a few special cases. By special cases, I mean any situation where the result is not two lines intersecting at one point. Now, there are two scenarios. You could have the same line or you could have parallel lines. So when you have a graph and you take a look and you say we have, let's go with y equals, we'll make it super easy, 2x, and y equals 2x plus, we'll go with 3. Just give us a little bit of room. So 1, 2, 3, 4, 1, 2. So to graph each of those lines, we're going to go with y-intercept of 0 for the first one, up 2 over 1, up 2 over 1. It kind of looks like that. And the second one, we're going to start a little higher, do it in blue. 1, 2, 3, up 2 over 1, down 2 back 1, and it'll look like that. So no matter what I do, if I had a better coordinate plane here, okay, and I went up 2 over 1, up 2 over 1, I'm never going to get to this line, which does the same thing, up 2 over 1. So it's like two staircases that are side by side. They're never going to intersect each other. So these are parallel lines, and you could look, without even graphing it, you can look right in the equation at the slope. If the slope is the same and the y-intercept is different, 0 and 3, that means they're going to be parallel. If the slope is the same and the y-intercept is the same, then you actually end up getting the same line when you graph it. Now you probably would recognize if I said, hey, let's graph y equals 2x and y equals 2x. Okay, you'd say, oh, well, those are the same line. Why would I have to graph that? That's kind of what you have to do when you see the slope is the same and the y-intercept is different. You said, oh, the slope is the same, the y-intercept is different. Why would I have to graph that? So that would be ideal. But it's not always as obvious. So sometimes you get something like this, 3x plus 4y, we'll go with equals 12. And let's go with 6x plus 8y equals 24. So let's go ahead and graph these two equations. And if I kind of think about this one, I can do the little trick with the x-intercept. That should be 1, 2, 3, 4. And the y-intercept would be 1, 2, 3. So my first equation is like that. And then when I graph my second equation, again, 24 divided by 6, that is 4. And 24 divided by 8 is 3. I get the same x and y intercepts, and my line lands right on top of the other line. These are the same line. Okay, so we really have two scenarios. We have a situation where we have parallel lines, and we have a situation where they're the same line. The bottom line, though, is we're looking for what is the intersection. So this one is no solution. Okay, there are no x values that result in the same y value. And this one is actually infinitely many solutions. It's always going to work. So x is a real, oh my god, I can't even draw that, is a real number. Any number for x will result in the same y value for each equation. So it's, another way to say it would be all real numbers. And that's looking at it as a graph. So let's take a look at what would happen in a scenario where we had substitution. So let's go with y equals 5x minus 10 and y equals 5x plus 2. So again, with substitution, I'm going to take all of one of these and put it in for the other y. So this one would be 5x plus 2 equals 5x minus 10. Now you should recognize right off the bat, same slope, they're going to be parallel or the same line. Different y-intercepts, you should recognize this as different lines with the same slope, so they should be parallel. But if you didn't recognize that, and a lot of people have trouble with that, so we're going to say What happens if we're trying to solve for x? Well, I'm going to move this x over. I'm going to subtract 5x. Okay? And if you have parallel lines, or if you have the same slope in your two equations, then all of a sudden you're left with no x values, and then you have just a couple numbers. If you have a true statement, then the lines are the same line. If you have a false statement, like this one is 2 is equal to negative 10, which is clearly false, that means that they are parallel lines. Okay, again, if it's false, they're parallel. If it's true, they're the same line. So it's really simple. If you actually had the same equation, let's just do a different one. 3x plus 1 and y equals 3x plus 1. Okay, obviously those are the same line. But if I didn't see it, maybe one was in a different form. So let me just change that up a little bit. Okay? What if I said we had 3x minus y equals negative 1? All of a sudden, that does look a lot different, aside from the color being different. So I'm going to plug all of this in for that y. So it's really 3x minus parentheses 3x plus 1, okay, equals negative 1. So I'm going to distribute this negative sign to get 3x minus 3x minus 1 equals negative 1. I can combine like terms, and these are going to go away. I'm left with negative 1 equals negative 1, which of course is a true statement. If it's a true statement, all real numbers is my solution. Okay? Meaning they're the same line. And that's special cases.